So PhD is for someone who, again, like I mentioned earlier, you will get a boost in your salary. You will get a better position. You will have higher chances of being selected for a certain position in an industry or a research institute, and especially university if you have a PhD degree. Like those are the main prerequisites now. When I started, the prerequisite for lectureship was a bachelor's, but time passed and then they changed that to at least masters, and now the times are changing over here in Pakistan as well, that and we've been hearing it for quite some time that, pretty soon the engineering council over here in Pakistan are gonna say that the prerequisite for teaching for a lectureship is at least PhD. I don't know what's higher than a PhD, two PhDs, three PhDs, but that's the main requirement. But a PhD broadens your mind. It's hard, it's tough at times. It is. I mean, it's not easy to do it, but with diligence, with perseverance, you get it. And once you have it, sense of achievement that passed this huge milestone. And people don't take that for granted. People who are employers, potential employers, do not take that for granted, which is why you get a boost in pay, which is why you get more opportunities if you have done a PhD and you're applying for a job. So if you want to go for it, especially in academia, you need that PhD.
Welcome to the Chemical Engineering Guys podcast, a show in which we share stories and tips from chemical and process engineers. We talk about student and professional life, as well as important aspects of products, processes, industries, and companies. But more importantly, what are the paths that these unique individuals are taking in this ever-changing world? Let's get started. So what's up, guys? Welcome to these new episodes in which Dr. Asim Hassan is now present with us, and he has been studying all around the world and also working, but now he's in the very interesting part of teaching students in the university. He also has a PhD doctor degree in fuel combustions, so that will be very interesting for those who want to explore more on what is the daily life of someone that studied a PhD doctor. So, Asim, can you introduce yourself? I don't want to steal your time. Please let us know about your background overall. Where did you live? Where did you study it? Why did you choose chemical engineering? And so on.
Hi everyone. Hi Manuel. Thank you very much for having me. I've been looking forward to this opportunity to just share a lot of information. So let's begin. Well, I grew up in the UK. My parents are both retired professors. My grandparents were professors, so I guess it's in the blood, teaching. So I have about seven other chemical engineers in my family. My dad, my wife, my brothers, my cousins.
Definitely in the blood.
It's definitely in the blood. A lot of people joke around. They're like, you guys can open your own university. Yeah, a lot of teaching. I mean, not everyone went into teaching. My brothers and my cousins went into the industry. So one of them works in the pharmaceutical industry. One of them is in modeling and CFD, all that stuff. So we have our hands dipped in different places in the process industry. So let's see, how did I get into chemical engineering? It kind of fell in my lap. It's growing up when my dad was doing his PhD. His area of expertise was in liquid extraction. Basically, what he did was he took the idea of the mixer settler, which occupies a lot of space and it's not that efficient, and he condensed it into something very small and highly efficient, which had a very high level of separation, known as the gull-wing extractor. Completely revolutionized the model for a perfect model for liquid extraction. So I was 11 years old at the time, and I used to watch him in his lab. That was in the UK at the University of Leeds, and I used to watch him doing his work, and that's what motivated me. I mean, I didn't know what it was, I didn't know what he was doing. I knew he was making something, doing his PhD, but I didn't understand it. Obviously, I was 11 years old. Growing up, I thought, okay, when I grow up, I want to do that. So I did my bachelor's in chemical engineering, to my A levels, and worked very hard for that. And then I thought, okay, let's do an MBA, because a lot of people at that time, and this is 2003, 2004, a lot of people after the engineering were doing the MBAs. And so I researched on it, and I found out, okay, you need some experience for an MBA executive. So I joined this company here in Pakistan in the city of Lahore, where I live currently, and it was an American-based company, and they worked with automobiles, Audi, BMW, Honda, Toyota, and they had offshored some businesses over here, and I joined that company. I worked with them for a year and a half, but it just and the pay was good, the salary was good. For 2004, the salary was very good, but I wasn't satisfied because I'd worked very hard in my bachelor's. I'd had a position, and I thought, nah, I need to get back into that.
So, Asim, before you end your work experience, what exactly were you doing? And can you tell us what was maybe the daily life of working, or maybe you didn't felt fulfilled? What was it that made you change?
Well, certainly wasn't the money. The money was good, but it's just that I worked very hard, and having obtained securing a position in my bachelor's, I thought I'm wasting my time over here. I need to get back into that field. So that was the main drive. That was the main drive, which made me realize. That was the main reason that made me realize I need to get back into the chemical engineering field. So I took a few months off after that job, after I left it, and then I just went back to the university and I joined. I said, if you have vacancies, just hire me. And I've been teaching. It's been 15 years now.
You got it easily, or did you knew some connections, or how do you got your current job?
Well, we have a rule over here that if you secure a position, either first, second, or third, their doors are always open. So I secured a second position. So they said, okay, welcome back. You can start teaching.
That's great. You always had this opportunity, so you went to the, let's say, industry, and you always knew that you had the probability of going back.
It wasn't an idea at the beginning when I started the marketing job, but later on, when I didn't feel happy with it, I realized, yeah, I still have that opportunity, so I need to take the opportunity. So yeah, I guess towards the end, I remembered. Okay.
It was something itching you on the back, something pending to be fulfilled.
Oh yeah, and I'm glad I did. It was one of the best decisions I've ever made in my life because, I mean, these past 15 years, I've learned so much, and from my learning experiences, I mean, hopefully, I've taught a lot of people, not only with chemical engineering, but with teaching. Other teachers will agree with me that students come to you with all kind of problems. They've got personal problems. They have so much going on. So I hope I've been able to, make a difference.
I'm pretty sure you have been doing, Asim. I want to explore a little bit more in the, I don't know, UK life. What did you liked about studying there? Or I think your PhD doctor was in Leeds, or was it also the MBA?
Oh no, I didn't pursue the MBA then. So
Oh, okay.
yeah,
You changed directly to PhD doctor, or you started working in the university and then later on went to the PhD doctor degree?
yeah, it was the latter. So basically, when I quit that MBA job, I went back to the university, started teaching, and that time, and this is 2005. Now they have a rule that you need to have at least a master's degree in order to be selected as a teacher. But at that time, they didn't have that rule. So I was selected as a lecturer, and then I did my master's. Because you have to have done a master's in order to apply for a PhD. So I was teaching and taking master's classes, and after that I applied for the PhD.
What was the master degree you were studying?
It was so as you know, there are two types of master's degrees. There's the taught courses one, and there's the one that's basically mainly based on research. The experimentalist that I am, I love doing experiments and research. I opted for the research-based masters. So my main focus was liquid extraction. I made up this. I fabricated this new equipment, and that was my my focus area of focus for my research project in my master.
So you were almost like taking the path of your dad, that he also,
Oh yeah,
that's
yeah.
nice. You went with the legacy.
Oh yeah, and obviously I reference a lot of his work in in my master's thesis.
So I think you did. Do you have the same surname and no first name? Sorry.
No, we have the same
Uh,
surname, but not the same first name.
That will be very funny to
Yeah,
reference. The students that will be reading that will be, why is he referencing
yeah,
himself? So that will be very funny, but
definitely.
that's great that you don't have the first name.
Yeah.
So let's explore more into this PhD. How did you went there? Did you knew you wanted it, or you were preparing for yourself to be more capable to teach, or the university was requiring you to get a PhD, or what started that little thing on let's go and start a PhD?
And I think it was about time because I mean, the longer you put it off, the more difficult it is for you to apply. I mean, as you're aware, there are also age limits for when you apply for a master's for a PhD. And I mean, I remember it was between you had to be not more than 40 or 45 years old. So I thought, okay, I mean, that wasn't the main reason. The main reason was the opportunity presented itself, and I went. The university paid for my education in the scholarship. The opportunity presented itself, and I thought, okay, the time is now. I need to take this opportunity now. If I don't, then I might not get a chance later on, and then it will be too late. So, if I'm being honest, I didn't want to be left behind. Opportunity was there. I started applying in different places. I had been awarded the scholarship, and they said, whichever university you want to go to, just apply. And if you get in, we're happy to give you the scholarship. So I applied in the States. I've got family over there. I thought, it'd be nice. I wouldn't have to give accommodation. I wouldn't have to worry about accommodation. So,
Always important to consider that.
oh, big time, big time. Having been through that, those are the questions people ask: how expensive is living over there, living costs and food and everything. So, but then I thought, I want to apply it back in the UK at the University of Leeds. So I did, and they let me in, and I even got a 20% discount on the tuition fees, and it worked out. Yeah,
So that's great. I really think it's very important that universities pay or value their own assets, which are the teachers or instructors. In this case, they knew that you were into teaching, so that I think is very great for your university that they actually sponsor you for you to go to study a PhD, which of course it's a risk in the sense that, well, maybe he gets a job or
yeah,
he wants to stay there. So do you have to sign something,
yeah.
or it's just, or okay, that you need to go back or at least pay the money? I imagine something like that. What
Oh
was
yeah.
it?
So I signed a bond, and everyone has to sign that bond, and you've got witnesses and everything. It's very legal, legal piece of document where you outrightly say that you're gonna go there purely, mainly for your education. When you're done with it, you come back, and based on the bond, you have to come back and serve 5 years, and then once you've served 5 years, then the bond is it's done with, it's null and void, and you can then choose to go whatever you want to. But it's like you needed help, you needed money, you were in a bad situation, and you went to your friend for money, and that friend helped you out, and then you didn't pay them back. So that's not very nice.
I totally get it. So I just wanted to ask because I don't know how it worked for you,
Oh yeah,
but I think it's very fair for the university to pay for you. But as stated before, they are investing uh,
definitely,
in this idea that you're going to get back and teach back to the same students, and because
exactly.
it's the money of the university, it will be very, because it happens also that you want to stay there because you like or you were offered a job, but
People do that.
but
I don't agree with it.
yeah,
I don't agree with it because it's a matter of integrity.
exactly.
And Manuel, when you think about it, when you come back, you're not teaching for free. You get that bonus for having completed your PhD, and you're getting your salary. So it's not like you're coming back and you're doing it for free. You're getting paid. So the least you can do is be grateful and help the students out. Why did you get that PhD? In order to help people out.
I hope everyone will see that way. But anyways, we're not going to discuss other people's life.
Yeah,
I'm also with you that it's giving back,
yeah,
is closing the circle, that they help you, you help the university, and the university helps students and also other instructors. And as you stated, it's one of the most important fields, chemical engineering. So I'm very happy that you decided to go back, because I don't know if you have this saying, but in Mexico we have it as well, which is, I will translate it literally, is brains are leaking or running away from the country
Yeah,
because the brains, the intelligent people, go to either UK, USA, or other countries.
yeah,
And instead of going back, they get very good positions, good
yeah,
salaries, good lifestyles, and they
yeah,
stay there. And instead of getting back and improve the country from their mother country or
yeah.
fatherland, they go and, well, the best people, which is very few, are going away. So that's sad.
I mean, the objective for a teacher is, and the priority should always, all the time, be students. I mean, I have students calling me on the weekends, even though they're not supposed to call me, or sorry, emailing me. They're not supposed. You don't email on your off day, but still, in these past 15 years, I've been available on weekends because it's part of the job. If someone needs help, you don't say, "Oh, I'm off today." That's. I mean, yeah, it's wrong if someone contacts you on the weekend, but I say personally, for a teacher's job, it's never off. You don't ever get any off time. When people need help, you should help them. That's what we're here for.
That's true. That's the slight balance between, also you need to make your time to be respected, but also you stated you need to help others when you can.
Exactly.
And if you're free and you have the time and you're not in something, I don't know, very personal, or if you're not busy,
Yeah,
definitely helping students is something important to do.
definitely.
Asim, I want to get more into the PhD itself.
Yeah.
What is the actual name of the PhD? What did you study? Which subjects did you study? And what was your thesis? And I think you also told me you went to Sheffield,
So
Newcastle
yeah,
for experimentations. Can you tell us more on that experience?
my research in my PhD started off with oxy-fuel combustion. So the objective was NOx control. As we know that NOx, in any form, nitrogen oxides are bad for the environment, for plant life, for humans. So considering that people have been burning fossil fuels for so long, and we have a hole in the ozone layer, that's all man-made. So these precautionary measures and these techniques were of absolute importance, primary objectives, in my opinion. That whatever flue gases you're throwing off into the environment, you need to know what ppm you're releasing these gases in, and they have to be controlled. That was a research project that was available, and this mitigation and this NOx control was brought about using this technique of oxy-fuel combustion, where instead of burning the fuel in air, the fossil fuel, you burn it in pure oxygen, which isn't very safe because the instrumentation.
No.
I mean, the instrumentation involved with it. I've seen it was a 450 kilowatt, just a 450 kilowatt pilot plant, and the instrumentation for that was just wild. It was an entire wall of instrumentation. This was the project that was given to me, but then they had some failures with the equipment, and then they had another project coming out, which was the use of fossil fuels, particularly coal and biomass, their blends, and certain air techniques and fuel techniques to bring about NOx reduction. So, in short, that's what I did, using fuel and different air introductory techniques and pilot 20 and 50 kilowatt pilot scale combustion plant. We brought about NOx control.
And was it all by yourself, the experimentation? So you selected the amounts of fuel and oxygen control, all that?
Like I mentioned, I went to Sheffield and Newcastle primarily. About 80%. Yeah, 80% of my pilot scale experimentation was in Sheffield. Even though I was based in Leeds, it's about a 1 hour drive, Leeds to Sheffield. The reason being that they had moved all their experimental facilities, their pilot scale experimental facilities, to Sheffield. It was on the outskirts of Sheffield. Engineering works over there, where the University of Sheffield and the University of Leeds had formed a merger, and they had other pilot scale plants as well for lots of other processes. So I used to go there twice every week and do my pilot scale experimentation. I did all my qualitative analysis, small scale in the labs at University of Leeds, and then I had an opportunity to work on an even larger combustion plant, about 100 kilowatt plant, but we kind of scaled it down because we could only run it at 50 kilowatts because we didn't have enough fuel to run it at 100 kilowatts. So the facility in Newcastle was amazing. If I remember correctly, it was Innovative Technologies. ITT. It was a company run by this billionaire, very nice guy, and he loved doing research. So he got together a lot of different people from different areas and fabricated all these equipment and put them under one roof. So I had the opportunity to work over there as well at a larger scale. And to be honest, it was new technology, brand new equipment because the equipment at Sheffield was a bit older. So it was a good experience. But yeah, different pilot scale levels. I worked on this experimentation, and we actually brought about NOx control, and it was really good.
That's good. Asim, I want to focus a little bit more on the human part.
Yeah,
And how was it to take your wife to UK? And because I know that she's also a chemical engineer, so
yeah.
I don't. Did she also study it, or she was helping you, or simply was at home? What she was doing for those 3 years?
Well, we're both assistant professors, and she and I both did our PhDs together.
That's great.
Yeah.
Same area or same topic?
Hers was a bit different. She worked with corrosion in these corrosion test rigs and different techniques to bring about corrosion, to reduce corrosion in process lines. So she worked on that.
Also in the University of Leeds.
Yeah, same university.
Same timing. Same. She
Same.
also got this scholarship.
Yeah.
So that's actually, I think that's very, I don't know if unique, but very hard to achieve, to be able to go study at the same time with your wife
It was.
same universities. For me, it's crazy to even imagine that with my current partner. So that will be very, I don't know, because she's a dentist or orthodontist. So
Oh, nice.
definitely
Nice.
very hard to find a place in which there's dentistry
Yeah.
and also chemical engineering
Yeah.
that lasts the same. So I think you felt lucky, or
Oh, very
how do
lucky.
you felt about?
Very lucky. For yourself, I'd say you have free dental. You don't have to worry about dental.
True, exactly. That's a advantage.
Yeah. But yeah, so we also had so I've got two kids, two sons, and my our son was 1.5 years old at that time, and it was tough. People wouldn't believe us. They're like, "You both are married, and you brought your 1.5-year-old son with you. How are you managing? How are you coping?" And yeah, I mean, I don't think I would have been able to do it without my wife. The support that she gave me, it was tremendous. It wasn't easy to be going through that time. You know, because a lot of people, what I don't like is so one of my master students just graduated 2 days ago. He had his viva, everything was good, and I'm very happy. So then people come to you for advice. Master students, once they graduate, they come to you for advice, asking you, okay, could you please help us out, give us information and advice on PhD, how to pursue a PhD, what to look out for. So yeah, I'm a very open guy. I'm a very straightforward person, and I guess that's why a lot of people approach me, and I guess in that regard, I'm approachable. So because I don't have that professor wall around me, I do have it to some extent, but I don't believe in that because then you're not approachable. So people ask me, and I just give them an honest answer. I said, you need to worry about currency. You need to worry about living costs. You need to worry about food, how you're going to support yourself. And ups and downs are just part of the PhD. I tell everyone, if you go to someone for advice on a PhD and they say, oh, it's fine, you apply for it and, just do your work and it'll be fine. That's just BS, man. That's complete bullshit. I do not agree with that. Those are lives.
That's
That person,
Yeah, that's true, but no one will tell you
no
that.
one.
So that's great that you tell them.
Oh yeah, I'm honest with them, because they need to know. Because what if I give them bad advice? What if they get stuck? I don't want to give someone advice and they get stuck at somewhere in their life. That's not my objective. My objective is to help people out as much as I can. Yeah, it wasn't easy. There were a lot of ups and downs. Like the worst time was when I was writing my first research paper. And guys, whoever is listening, if you're students, back up your work all the time. Like for me, I'm the kind of person who backs everything up all the time, but I'm only human. I make mistakes. So I was doing another job in the neighboring department of mechanical engineering as a receptionist. It wasn't bad. It was about £9 an hour, which is very good. I mean, you don't have to go off university, off site, and look for a job. The job is right there, and that's a good pay. So I was busy with that, and I had other stuff in my mind, PhD related, of course. And I was busy writing my first research paper. And for postgraduate students and for graduate students, they know that the first research paper is very, very important. I had not backed it up. I had a flash drive, a Corsair 64 GB flash drive. I still remember it. I've still got it actually, and
Well,
I had not backed it up. I mean, I was using Dropbox. I was using my Hotmail, everything to back everything up. That thing, I don't know why. I just can't explain why I didn't back it up. That flash drive got destroyed, and I lost that work, and I had to start from scratch. I mean, it wasn't that difficult because I knew what to write, but it is difficult when you have to reproduce something you worked so hard on. Like number one advice,
sorry, how many hours was that in time or worth for you?
that was about 4 months of work.
Oh,
Yeah,
or lost? Well, not lost, as you stated. You know the structure and the results and all, but you
definitely.
need to rewrite it everything. So that's
Yeah, but I mean, bad things happen, but those aren't the kind of bad things that should happen. Take my advice. Everyone is listening. Please back up your work. Make sure it's backed up online. Hard drives are fine, but backing up online, Dropbox, your Google Drive, it's the best thing. Do not make the same mistake I made.
I usually try to back up at least 2 times. Normally, I try
Yeah,
3 times online, physical, and via email. So definitely
yeah,
not going. If something fails, and it can happen that two things fails at the same time,
definitely.
it's very strange, but it can happen. So why not three or even more? Especially if it's
Yeah,
like a thesis in which you're literally using your time
yeah,
for that.
yeah.
It's very important to do that.
Definitely, definitely.
Asim, and what do you want to say related to PhD for other extra tips or
Yeah,
maybe how's life? Whatever you want to tell us on the PhD
yeah.
topic so we can pass to the instructor part.
Would you like me to talk about my work, or because I'd love to give advice on potential PhD
Sure.
students?
Whatever you think is relevant. I'm pretty sure there's people interested maybe in going to the UK for study, maybe someone in your case that it's in the university and thinking if he should go or not or take the opportunity. I think chemical engineering profiles
Yeah,
get repeated in
yeah.
certain ways all around the world. So whatever you think is valuable, I think they will also find it valuable.
Well, the thing is, for a graduate student, when they're looking for higher studies, I mean, number one, first we have to segregate these things into two pathways. Number one, you either want to go into research, or you want to research and academia kind of go hand in hand, because there's no academia without research. Because when you're researching, you're learning and better educating yourself. I mean, considering you're the instructor, and the more you educate yourself, I mean, if you think that after PhD that's it, I've learned everything I wanted to learn, you are very mistaken. I think that you actually start learning, like the journey as an instructor starts after your PhD, because you learn so much in your doctorate and your postgraduate studies that your mind opens up to so many things. So it's bad to think that once I've done my PhD, that's it. I've learned everything. No, you can't go on with that attitude. You can't move forward or be a good instructor with that attitude. So and particularly when you're applying for a PhD, if you want to go into teaching, then you need that PhD, because there are a lot of places which won't give you a job without a PhD degree or a master's degree at least. Now, if you want to go into industry, times have changed. Back in 2003-4 when I graduated, you could easily, I mean, I know people who are now plant managers or general managers of different process plants, chemical plants, and their qualification is just a bachelor's, and the rest they gained from experience in the process industry. But now times have changed. Now industries, you do get a push, you do get a boost if you have a master's degree. Now the next most important question is, what do I do further studies in? What do I do my master's or my doctorate in? And this research is done on a global level in order to better the society. Like all these subjects, all these research topics that are offered, that professors or instructors offer you, they are to better the society, meaning they're based on what's going on in the world right now, and how once you've attained that information, how can you help the society? So nowadays, a lot of work is being done on alternative fuels, zero emission technology, green technology, whatever you want to call it. It's the same thing. And people have, which is ironic because my PhD is with fossil fuels, but so now everyone has moved away from fossil fuels. I mean, if you look at the last 10 years, a lot of like Big Coal, one of the leading manufacturers of mining companies in the United States, they went out of business some years ago, which, and this is the kind of company that in one interview with either, I think it was Newsweek or Time magazine, they gave like a 40-year projection, like, oh, in 40 years, we're going to be here, we're going to be over there. So a lot of big companies went out of business, which is further proof that people have moved away from fossil fuels because they give off all these dangerous, harmful emissions, and it's not cost effective to then include retrofitting in order to reduce those emissions. That takes up a lot of energy. It's not cost effective, and it reduces the overall plant efficiency. So people have moved away to renewable energy, renewable forms, cleaner energy. You've got solar, wind, hydro, so many different things. And a lot of people are also working on water. After you've done your degree, you can even go in food, you can go into pharmaceuticals. The main objective is, when you're going for higher studies, is to choose a research topic which you can actually use. Don't just do it for the sake of doing it. That's just wasting time. I mean, it takes 1.5 to 2 years to complete your master's, and then between 3.5 to 5 years to complete your PhD. So that's a large chunk of your life, and a lot of time you're investing in yourself. So it has to be done in a topic which the experience which you can use later on. So that is very important. A lot of people just like they say, okay, we'll just do a PhD and whatever. You can't do that. Once you start doing a PhD and you're under stress, and believe me, you will experience that stress. At times, you question yourself. You're wondering, why am I doing this PhD? I'm going to quit. No, that means everything is good. I mean, it may be bad. It may sound bad, but it's actually good. If you're having a tough time, that means if you're having a tough time, that means that the challenge is on. It's like a jungle. You've been thrown into the jungle, and you have to learn new techniques to survive. That's just how it is. PhD is never easy. But I'm not saying it's not achievable. I did it. Thousands of people have done it. Put in the hard work, you put in the time, you can definitely do it. But it has to be a topic which you can use later on. You have to create your self worth. That's what I'm trying to say.
I totally agree with you. And Asim, I want to get a little bit more not controversial but honest. So say from a scale to 10 to 10,
Yeah,
do you, in which number of proportion would you say of preparation, intelligence, and compared to your other fellow students, would you position yourself? For example, I don't want to be egocentric, but I will say I was,
yeah,
or I always felt that I was on top, maybe
yeah,
top eight, nine.
yeah.
And for me, it will be very, when I say people, it can be done. Of course, it can be done, but if I found it easier than other of my fellow
I know what you mean.
classmates
I know
that
what you mean.
were studying much more and they concentrated even more time and read much more. So, what would you say? And which PhD colleagues would you say I wouldn't believe that he could make it and he
Yeah.
made it? And reverse, maybe you say this guy had the best abilities and could
Mm.
never done that. So, do you have some experience and
Yeah,
how?
that's an interesting question. Uh, so yeah, I agree with you that I used to have issues with mathematics, and my dad, he was amazing at mathematics. He taught me mathematics. This is back in 92, 93, and I never had issues with mathematics since. But at times, I also felt that these things were kind of easy. I understood them at a faster rate than other people, and not trying to sound arrogant. The different types of people, that they're hardworking types, they're intelligent types, they're people born with talent. I say I was talented, but I also had to work hard for what I had for what I've achieved. But out of 10, I don't know. I'd say I was a 9, and the reason why I'm saying 9 is because 10 would be that I found perfection, but I'm not. I'm not a perfect person. I don't know everything. I know a lot about a lot of things, but I don't know everything. So that's why I would rate myself at 9, and because I'd say I've worked hard. I've worked very hard to get to 9, but I'm not a 10. I can never be a 10. We can never be. We can strive to be a 10, but we can never be 10s because we're imperfections. We can try to be perfect, but never be perfect. And that's what I said at the beginning. That if you believe that you've learned everything, then that's it. You should not be teaching because that's what you will pass on to your students. You'll pass on overconfidence. And that's not what you want to teach young students, to be overconfident. That's just wrong.
You want to make them curious,
Yeah.
and you want to teach them how to learn, not exactly teach them stuff, but to learn.
Exactly. Like, and you don't want to teach them to. You want to teach them to be modest and humble and not arrogant. That arrogance is. I don't like arrogance. It's nice when someone's talented. It's good, but arrogance just ruins intelligence. So someone can be the most intelligent person in the world, but if they're arrogant, then I don't know. That's just my opinion. That's just how it is. But with regards to
I'm with you. I'm with you.
yeah, with regards to your other question, were there any other colleagues which you were surprised? Yeah, I know a few people. So basically, my work was all based on pilot scale testing, pilot scale experimentation. But I do know some people who used to spend all their time in labs on a little workbench doing lab scale testing, lab scale experiments. I did a lot of lab scale experiments. I did about I don't know, 5 to 600 lab scale experiments, successful and failed experiments. And that's just apart from the pilot scale testing I did. If someone asked, okay, did you do more process work than other people? Then I would say, yeah, because that's the truth. Because process isn't only in beakers and in the lab, in a burette or in a condenser. Process engineering occurs in reactors, it occurs in heat exchangers. You need those kind of things. That's what a process is. It comprises of all these different process equipments. So I believe if you haven't used them, then that's not really a PhD in chemical engineering. That's more like I don't know, physical chemistry.
Chemist.
Yeah,
Exactly. Well, depending, but yes, definitely. If there's no steel, if you're working with glass, probably it's not that quite relatable to chemical engineering.
unless it's
So,
a reactor made out of glass. You know.
oh yeah, true, true. Or unless you're actually working with
Yeah,
chemicals related to glassware or something like that.
exactly.
Asim, let's pass to the actual part,
Yeah,
which we already talked a little bit about. How you told me you were teaching 15 years already,
yeah. It's been a long time.
and where is the university located? What's the name? What's the bachelor like in the university? How or what is the main topic?
Hmm,
Do you teach in bachelor,
hmm,
university, and PhD?
hmm.
And what topics do you teach?
So I'm just going to type out the name over here. So I teach. I live in the city of Lahore, and I've been teaching at the University of the Punjab, which is also known as Punjab University, because not everyone likes saying University of the Punjab. So, to my recollection, we have about 40,000 students, not just in chemical engineering, in this university.
Overall,
Yeah, about 40,000 students, and it's a massive university. Luckily, I live just 10, 12 minutes away. So I don't have to traverse long distances to get to work. It's very
you go to
convenient.
work by car, public transportation, bike.
I drive. I have my own car. So our institute is, I think it was in 2018. It was 100 years old, and we offer bachelors in pure chemical engineering. We have specialization topics such as oil and gas. We offer coal specialization, and we also have a master's program. We also have a PhD program. So I've taught fluid mechanics, heat transfer, particulate solid technology, reaction engineering, maybe forgetting one. What am I forgetting? Transport phenomena. Taught all these in bachelor's. In master's, I've taught advanced chemical reaction engineering. In PhD, I've taught fuel and combustion. So these are the topics I've been teaching in the past 15 years.
And which one do you like the most to teach?
Based on all the crushing and grinding I did in my PhD, because when we received the coal in the UK at Leeds, it was in lump form, even though we'd paid about £2,000 for it to be, for it to be ground up to 135 micrometer average particle size diameter. So when I received it, it was in lump form. So I did a lot of size reduction, and so having experienced that solid technology, to be honest, I find that easy. It's I don't know. The more you teach it, you find it easy. Some things you just click with. So based on my practical experience, it helped me in giving practical examples to students and helping them further on how to actually use these equipments. But that's not my favorite topic. I'd say reaction engineering and transport phenomena, because I can't say fluid dynamics, fluid mechanics, mass transfer, and heat transfer all together because I love all three. So transport phenomena and reaction engineering, I love these topics the most.
I love reactor engineering overall, but transport phenomena is
Yeah,
not quite my let's say favorite
yeah,
subject to say. So
yeah,
I really I don't know. It's very between abstract
yeah,
mathematics and actual application. So
yeah,
well, anyway, we can in another episode talk more about the actual teaching of
definitely.
transfer phenomena. That will be great, actually.
That'd be nice.
What I just want to know more into what do you see like the future of instruction or teaching in universities, because I hear a lot of this more in the US that the chemical engineering bachelor or
Hmm.
field is dying and that students are not any longer interested in going to chemical engineering. What do you say is the overall, not the actual field, but the study? How do you see it's going to grow? Has it been growing or decaying as time has been passing? What's your thought?
Well, I mean, when the economic crisis took place, it took place globally, and people had problems with the job market because there was a lot of competition going on, fierce competition over here in Pakistan, because there were very few positions that were being offered. A lot of people had been laid off. People were offering very few positions. So, based on this current statistic, I'd say that yeah, there has been a decline in students applying for chemical engineering. But the thing is, no matter what happens in the world, you will always need doctors. Like to survive, human beings need water, clean water. Human beings need food, and human beings will always need medical care, right? And human beings will always need, I mean, if you want to grow crops, you will need fertilizer, you will need medicine, and who is responsible for manufacturing these things? Chemical engineers, you know, process industry, who runs that? Chemical engineers run that. So I mean, even if everything dies out, actually, no, that's a bit too far, but yeah,
Yeah.
like zombie apocalypse and stuff, right? But no, like process engineers are a vital part of the society and the industry and all the markets out there. I guess people are more attracted to other things now, like people want to go. Like media is responsible for that. I say Hollywood is also responsible for that. Like kids nowadays, they see robots and they see hackers and stuff, and all these TV shows. They think, oh, I want to go into computer programming, or I want to go into game design. You know, I personally like game design because I'm a gamer myself, but that's beside the point. But it's the media which also change, molding people's minds, young individuals' minds, into thinking that they need to do something else, which is fine. All these degrees are good, all this professional education is good, but your original question, that how is the market now? In the past 6 7 years, I have seen a slight decline. Not a large decline, but for process engineering. But that's not to say that people are not interested. Still, people who like students. You get to talking to your students, and like on average, I meet many students who actually wanted to do process engineering. I guess that's how the times are. A lot of people change their minds; they want to do something else. But times change, and people want to do whatever professional education they want to do based on what's going on in the world. But what's going on in the world is basically, we need to have the know-how on how to preserve this environment, and chemical engineering teaches you that. So I'd say, if for those young people who are listening, if you want to go into process engineering, definitely go for it. You learn a lot of things because after process engineering, like myself, at one time I wanted to do my MBA. You can couple your bachelor's with an MBA, and that just widens your horizon so much. You can do so much. You can go into paints, you can go into pharmaceuticals, fertilizer, you can go into research. There's so much you can do with this degree. Whereas with other degrees like electronics and stuff, you're kind of just pushed into one corner. I mean, again, my opinion. But with the chemical engineering degree for your bachelor's, you taught electrical engineering and mechanical engineering in your first and second year, and that's to a high level, not elementary level. That's to a high level. I think in this degree you learn quite a lot, and you can be suited for different places in the industry.
Totally agree with that. Chemical engineering is still, in my opinion, a active field.
Definitely.
There's a lot of things remain to be done. On even though the students don't want to go to chemical engineering,
Yeah.
some engineers are going to take process engineering and chemical engineering fields. I will also say maybe biotechnology fields are growing, and maybe that's why we see a small decline in chemical engineering
Yeah.
or maybe pharmaceutical related fields that before they were not so
Vast.
big
Yeah.
to be included in a bachelor
Yeah.
level. But now I think that people is getting more specialized, and universities have seen that, so they are
Yeah.
making more specific profiles for the industry.
Definitely.
Asim, I don't know if you want to add a little bit more into instructor or your teaching, anything tips to students, or shall we pass to the quick questions?
Yeah, just some advice for the students. Don't talk in class. Attend your classes and I take notes. That's the advice I give all my students. So many times I have students, like I make my lectures. I mean, I try to make them interesting. I've got graphics, I've got videos, because students don't want to look at just people, the instructor writing on the whiteboard. People don't. I don't find that interesting. So why should I expect my students to find that interesting? So, I've got videos, I've got visual aids, all these things. So you can't just sit there and just expect to absorb this information because again, for the students, you're learning. So you need to have notes. So class notes. Do not, please, I've said this for so long. I hate other people's notes because everyone is an individual, everyone thinks differently. So let's say someone wrote notes, and this is a big problem in many universities where juniors, they just find some notes from some seniors and they'll just start using the notes, and a lot of those times those notes are incorrect. They have huge blunders in them, big mistakes, which these students start copying and they start reproducing them in their exams. And when they don't get a good GPA, they come to you and they ask you, sir, but I did everything correctly. I'm like, no, you use someone else's notes. So class notes, taking your own notes is of the utmost importance. That's my main advice.
One way to understand, or not to understand, but to get inside of someone's mind is to get to read his notes or
Yeah,
her notes. You will see how drastic it changes
big time.
the logic, the things that you think are important
Yeah,
typically are not present in their notes,
yeah,
and maybe some details. I don't know. It's a very quick way to see how a brain of other people
yeah.
works.
Oh, and ask questions. Always ask questions. Do not feel bad what other people will think. If you don't understand something, there's no need to be embarrassed about anything. Again, you're paying for that degree. So you have every right to ask your instructor questions. So take notes and ask questions. That's the advice I want to give.
So let's pass to the quick questions. I don't know if you read them in the booklet I sent you. If not, it's even better.
I did. I did.
Okay, so you have an idea of what we're going to be asked.
Yeah, but I've forgotten them.
If you could add something to your bachelor syllabus or courses,
Hmm.
and it can be anything.
Yeah.
I don't mean technical stuff. It can be whatever you want. What will it be?
For the topic I've been teaching mainly, I forgot to tell you, I recently started teaching natural gas engineering. So for the syllabus that we're teaching right now, it requires we should be having some lab work. So we don't currently have lab work for natural gas engineering right now, which I'm teaching to third year students. So that would be fifth semester students. So lab work is very important in process engineering. I mean, I can't stress that enough. So we need that right now. So that is going to be included very soon.
Lab work overall.
No, just for this topic. Like we have a
Oh, okay, okay, okay.
capable labs with state of the art equipment. But for this particular topic, we need experimentation, small scale experimentation, not large scale.
Second question: what do you regret from your bachelor or student university life?
So this is really funny. My friends still make fun of me. So, like I mentioned, I worked very hard doing my bachelor's, and so towards the end, I was getting the first position. This is before the final year exams. So, like plant design was one of my favorite topics. It's still one of my favorite topics. So, what I did with heat exchanger design, shell and tube heat exchanger design, was it used to take about an hour and 15 minutes to complete the entire question, starting from the beginning right towards the end when you find the pressure drop for heat exchangers. So I kind of devised a method to reduce that time and still be able to complete that method of designing a heat exchanger. So a lot of people came to me in the final year and they're like, "Hey, Asim, help us out, man." So I helped nearly my entire class, and the class at that time used to be about 100, 120 students. Now, over the years, class sizes have been reduced, mainly because of the engineering council over here in Pakistan, because of the student to teacher ratio. It has to be a certain ratio that you can actually get your point across to the students. If you have too many students, then it gets kind of difficult, more challenging. So the engineering council reduced the number of students inducted into classes every year into the program. By that time, it used to be 120 students. So my entire class came to me, and I kind of taught them how to design pressure vessels, cost estimation, heat exchanger design, all that stuff. And when the exam time finally came, I don't know how I did it. I got the lowest marks, and all of them got more marks than me. So that was just, still think about that sometimes, but yeah, that's one of my, I guess it would be a regret. Yeah, it would be a regret.
Regret of teaching all the people and not getting the correct grade, or what?
Just regret that I kind of messed up in the exam, but that's proof.
Oh, okay, okay,
That's just proof that no matter how good you're doing, we're only human, and
exactly.
we make mistakes. So stuff happens.
Okay, I see. Underrated things or stuff in chemical engineering.
Underrated. I guess the horizons that open up for you. People are under the misconception that you're very restricted to certain jobs afterwards, and I disagree with that a great deal. Like I've met people who, after their bachelors, they've been working for McDonald's. I mean, McDonald's is food industry, right? So people work for Nestle. People go into pharmaceuticals. People do their MBA and they move into like a completely marketing or management based environment. So this degree gives you a lot of information about. It basically prepares you for not just one particular type of like Liam Neeson, not a particular set of skills. You get a lot of set of skills through this degree. So I think that's where this is underrated. For those people who consider it underrated, so I would say this gives you this particular degree widens your horizon. You can do so much with this degree.
I'm with you in that. Chemical engineering has very crazy fields, and especially that's what I want to cover in this podcast, to see all the different profiles that chemical engineers
Yeah,
have been taking in this crazy world, because there's a lot to do and you don't know where you will end up.
yeah.
So, Asim, what would you study other than chemical engineering? Maybe
Hmm.
let's say that you go back in time and you say yourself, you cannot study chemical engineering. What would you choose?
I remember this question. I was reading your PDF. I thought, I mean, firstly, I want to say that was so nicely done. The PDFs that you sent me, very nicely composed, and the questions. I mean, I'm very, very particular about proper composition, typing everything out, formatting. Oh, like I'm very OCD about that. So that was very nicely done. So I remember this question. I remember thinking if that when you asked me what I would say, and like I've been a gamer since the age of 5. So that's about 35 years I've been a gamer. And if I hadn't done this degree, I would have gone to game design, without a doubt. No questions asked. Gaming design.
That's cool. That's a very, I don't know, I wouldn't expect that from a chemical engineer, but that's the point.
Yeah.
That's great. That's great. So, okay. who is a PhD for, or who is the perfect profile?
So PhD is for someone who, again, like I mentioned earlier, if you want to go into academia, a lot of companies, a lot of universities, not companies, uh, well, a lot of companies as well now, they, you will get a boost in your salary, you will get a better position, you will have higher chances of being selected for a certain position in an industry or a research institute, and especially university if you have a PhD degree. Like a lot of people, a lot of places are now like those are the main prerequisites now. When I started, the prerequisite for lectureship was a bachelor's, but time passed, and then they changed that to at least masters, and now the times are changing over here in Pakistan as well. That and we've been hearing it for quite some time that pretty soon the engineering council over here in Pakistan are gonna say that the prerequisite for teaching for a lectureship is at least PhD. I don't know what's higher than a PhD, two PhDs, three PhDs, but
Maybe
that's the main
postdoc.
requirement. But a PhD broadens your mind. It's hard, it's tough at times. It is. I mean, it's not easy to do it, but with diligence, with perseverance, you get it. And once you have it, there is a sense of achievement that passed this huge milestone. And people don't take that for granted. People who are employers, potential employers, do not take that for granted, which is why you get a boost in pay, which is why you get more opportunities if you have done a PhD and you're applying for a job. So if you want to go for it, especially in academia, you need that PhD.
Interesting. That's, I don't know if I fit in the profile, but I will see. Previously, I wanted to go into a PhD, but
Yeah.
right now I don't. I'm not quite sure.
Mm.
And I just stated, if you, I don't know, you need to have a specific profile to enjoy doing a PhD.
Mm.
Anyways, let's pass to the professional life questions.
Yeah.
What are the top skills that every chemical engineer must have?
Ooh, number one. Well, people say that you need to have your chemistry concepts need to be perfect and A1. I disagree with that. Basically, you need to know where to get information from. Like, yeah, yeah, you need to know a lot of things by heart. You need to be able to understand concepts. But people say that you need to have everything at your fingertips. That's not true. We're human beings. Even I forget things at times. That's just how it is. I'm a human being, and I can't stress this enough. I've said it so many times during this chat with Emmanuel that we're human beings. We're not perfect. We tend to forget stuff, but your concepts need to be clear. And if you forget something, you need to know where to get that information from. Like a lot of people just refer you to Perry's engineering handbook, but when you think about Perry, like that's a classic get out of jail card, right? Get out, get out of jail free card. If you can't explain, then hey, refer someone to Perry's engineering handbook. But when you actually go through Perry's engineering handbook, you find out, wow, actually contains a lot of information, which it does. So your concepts need to be clear. You need to be constantly reading up, keeping your concepts fresh. Because again, we're human beings. Okay, I'll give you my example. I always give my example that when the year and a half that I worked for that marketing job, and even though I had a position, I worked hard for this, I still started to forget things. And I realized that when you move away from a certain field, being a human being, you're concentrating on other things, you tend to forget something else you did beforehand. So I had to, when I got back, when I applied for the job, for the interview, I had to go through my books again. That's just how it is. So as human beings, because we tend to forget, things. You need to keep your concepts fresh, constantly keep on reading. A lot of bachelor's students, undergrad students, don't research papers. So, this kind of thing, this kind of practice has only started. It's only begun for masters and PhD students. Well, at masters and PhD level, it's absolutely imperative. It's of absolute importance that you read research papers. But even for bachelor students, like I tell my bachelor students, hey, if you're reading about fuel and combustion, go through the books, fine, but also read research papers on, recent research. So you educate yourselves on what's being done nowadays, what's new, what are the new techniques, what are the new objectives that are being done, what are the conclusions. So if you're not doing it, start reading research papers as well.
I also think the same. You need to learn by yourself, and university will not typically teach you that. That's up to you.
Yeah.
Okay, so this one is interesting.
Yeah,
Who would you like to trade jobs for one day?
yeah.
And you can select several jobs depending on the time. For one day, for 1 week, for
Hmm.
1 month, and
Mm.
for 1 year.
I always wanted to be a medical doctor because I've got a lot of medical doctors in my family. So I've always been interested in how the body works, anatomy, and all that. So, and I know it's not easy. It requires a lot of dedication. Not that chemical engineering doesn't require a lot of dedication, but I'm just saying that the area of medicine requires a lot of dedication, hard work. So I would say maybe for a week, not more than that. I don't think I'd be able to do that. But if I had to trade places, I would do it with a doctor because, again, that's another job where you get to help people out. So yeah, I trade places with a medical doctor.
I have this question,
Yeah,
which is kind of funny, but might not be funny.
yeah.
How often do you use the Laplace transform?
I think I know what you're going to ask. Yeah, and it is a funny question. Yeah, please go ahead. Go ahead. How often did I use Laplace transforms?
How often, or did you even use them in a job?
Oh my god. That's a question I used to ask as a student because we did Laplace transforms in bachelor's and in master's. And I could do it. You trigonometric functions, fine. You get to solve those questions, fine. But then I would ask myself, when am I ever going to use this? Because if I mean, maybe you could use it for modeling, but then for modeling, I mean, I did a bit of modeling. I did a bit of CFD. For CFD, you use Fluent or you use other softwares. Everything is done for you. All you have to do is take data and just input it into those softwares, and it runs the iterations, and you get your results. That's it. So my answer would be no. I've never used Laplace transforms ever. Practically, I've never used them because everything's automated. You just push in you just input the information into the software, and you run it, and that's it. It gives you the output. So I've never used that.
That's very important to detail that we learn the math just in case that you need to go back and verify it for yourself. But typically, everything or all that fancy calculations are going to be calculated in a
Yeah,
computer. So the important part is to actually understand the results.
exactly.
And if they're in some cases, very strange cases, you might see that you follow the path and eventually you see, well, I will need to go to see why this failed. And then you end up learning the model and then you see the Laplace transform.
I completely agree with that. If I may add, I'm not saying that it's useless. I'm not saying that. Again, to potential students or current students who are listening to this, I'm not saying it's a waste of time to study. No. I mean, firstly, you can't graduate your instrumentation or process control subject without that. But the thing is, if you don't know the theory, if you don't know for chemical engineering students and for chemical engineers, if you don't know the working principle of something, then when the automated process fails on you, you will not be able to save it, right? And that's what differentiates you from a capable engineer and from someone who doesn't know what the hell's going on. Like these computers, these are all man-made. These machines are all man-made. If they fail and you don't know how they work, then you will be at a loss. So yes, I'm saying I've never used them, but I know enough that if something fails, if a model fails, I can find the mistake because I have concepts of Laplace transforms. So being knowledgeable about them is very important.
Exactly as you stated, the idea of at least knowing the fundamentals help you a lot to get a deeper dive. So, last question in the professional life section.
Yeah.
What do you think is going to happen with chemical engineering as the industry 4.0 comes here? I don't know if you're familiar with this concept.
Okay. I was kind of reading about that recently. And basically, we've been moving from human workers to, correct me if I'm wrong, basically, that's the new rule under which everything is being moved to the automated process.
Exactly. Automatic, all is in the cloud or all is connected, all that.
Well, number one thing is security. Like, actually, with regards to jobs, by automating the process, definitely you are taking away people's jobs. I don't agree with that because again, this is all man-made. There could be issues, there could be problems. So when a human being is in charge of a process, it's not as efficient as a machine doing it. But in many ways, I think like we on paper we will say that a machine is more efficient and more effective is more efficient than a human being, right? For example, if you're running iterations, any CFD software such as Fluent can run millions of iterations in a specific amount of time. A human being cannot do that. You can't do 1 million iterations in 1 hour. Human beings cannot do that. So when it comes to efficiency, yes, machines are more efficient than human beings, but when it comes to effectiveness, I say still human beings still have more points, because again, human beings made the machines that help us. And when it comes to human beings taking care of a process, unless you have an actual human being running, like a shift engineer, for example, a shift in charge, he starts his shift, he checks all the different components in along a line, he checks all the instrumentation. He talks to the operators. He checks, okay, are the input outputs according to the requirements? Are the temperatures, all the process variables, under all based on the requirements? Is this what it should be and everything? You can't expect a machine to do that. So these new rules or this new style of changing the fundamentals of the industry, I don't completely agree with that. We will still need human beings, and with regards to uploading everything online, there will still be issues. I mean, with these things, security is number one when it comes to uploading data for a certain process plant. You know, security is a big issue. People could hack in. I don't know. I'm just thinking of possibilities. I don't 100% agree with it. That's what I would like to conclude with.
Okay, okay. Well, let's see what
Yeah,
happens for us in the future. But I also think it's very interesting
yeah,
about the chemical engineering role in this new upcoming
mm,
thing. So one thing I really liked about the idea in process engineering was that, for example, I had to go to the actual machine and check out the results, and then
yeah.
I don't know. It will be. I always thought, why is this not
Control
connected
room. Yeah,
to a network in which I can just go
yeah,
online and connect all the data and try to have a
yeah.
unified system? So I think that's a good part of
Definitely.
this. The bad part is maybe all the job loss, which clearly is going to happen as with every revolution on the industry. But well, that's hopefully a couple of years far away.
Yeah, it's gonna come over here later though.
So yeah, yeah, for sure. 10 years, hopefully nothing happens.
Yeah,
Now, same random facts just to end
yeah.
up our chat. Coffee, tea, or energy
Oh,
drink?
I've never had an energy drink in my life. No one believes me. I'd I'd go with tea. I'd go with tea.
Was it because of the UK or?
Over here in this part of the world, in Pakistan especially, people love tea. So we're not.
Oh, okay.
We're more tea drinkers than coffee drinkers. So I don't drink it that much, but if I had to, I'd choose tea.
Okay. Which hobbies do you want to develop,
Mm.
or have you ever had? I don't know, maybe to play piano, but you want that you have always wanted to add to your repertoire.
Oh, I'm the kind of person who likes a lot of things and likes a lot of balls in the air, so to speak. So I grew up learning music, playing piano, flute, wind instruments, never played the guitar. Big on sports, table tennis, played that at a national level. Mountain climbing, I went crazy with that at one time. Snow climbing, rock climbing, all these things. So yeah, I've done a lot of things. I guess they would be interesting. You could call them interesting over the years. Oh, fish! I love fish. Keeping an aquarium. So I love doing lots of things, keeping myself busy.
Aquarium. I also always wanted to start my own aquarium and feed the fishes, but
Ooh, nice, nice.
I think it's a lot of work and a lot of
Oh
research
yeah,
as well.
definitely. But it's when you think about it, it's all chemical engineering because you have to calculate the flow rate and the. I mean, I think yeah, it definitely is because whatever. What do you call it? It's the water circulation device that you use in that the pump. Sorry, the water circulation pump. The pump that you use in that has to be. It's based on the volume of your tank, and you have to find out. Okay, how many cycles of based on the flow rate. What flow rate do I need to keep this clean? And you have to study the nitrogen cycle as well. That's what I did when I started keeping an aquarium, and I realized, oh my god, chemical engineering is a part of everything, man. So yeah,
That's very interesting. I also see a lot of chemical engineering things in daily
Definitely.
life. So it's impossible once that you go to the rabbit hole, it's impossible
Yeah.
to go out.
Definitely.
So Asim, we are done with the quick questions. I don't know if you want to make a final conclusion of the episode or things, tips,
Definitely.
whatever you think to is
I,
right.
I just want to thank you again for this opportunity. I've been following your wonderful YouTube channel for quite some time, and it's a pleasure finally to talk to you and to share thoughts with you. Even though I apologize, I'm the one who was doing most of the talking. but
Oh, that's the point. That's the point of the episode.
So thank you for the opportunity, and I wish you the best of luck with this endeavor. And I think it's a really good thing that you're doing. You know, talking basically you're networking, right? You're talking to people in the same field, and you're. I see what your objective is. Your objective is to help people out, and that's your objective. I'm all for it. You know, whatever support you need, I'll be more than happy to help you out. And so, yep, I'm on board with your thought process, and I appreciate that, and I respect that.
Thank you. I really appreciate it, Asim. Thank you for joining the episode and giving us that much input into what is to be a chemical engineer in a family of chemical engineers, and also instructor, PhD. All this is very important. And I just stated this show is
Yeah,
for that, to and meet other people that I know, especially as a student, it's very hard to
yeah,
imagine a chemical engineer life.
yeah,
What do they do? Do they go to the
mm,
industry? Do they go to companies that
yeah,
work in finance, banking? Do they work in a research lab? Do they go to the university to teach? I think there are many ways in which we can
yeah,
fit in the
yeah,
world. And this podcast is just for that, to share our stories and let other people know
yeah.
what we do, especially students in chemical engineering, but also other engineers that I don't know. I typically hear and say, I don't know if you saw Rocky versus Drago.
Oh yeah, but I'm a big Rocky fan.
Okay, so that guy studied actually chemical engineering, Drago.
Yeah, he's got Dolph Lundgren. He's got a master's in chemical engineering. Yeah.
Exactly. So it's very funny. Where do they end up?
That's the thing. You know, you don't know where you'll end up. But basically, if you want to stay in this field, you have so many opportunities: industry, research, teaching. You can do so much with this degree. So it's like I said before, it's a misconception that you restricted to just one area. No, you can do so much with this degree. And if you decide to change it, fine. It's not a big issue. You know, you have a base. You have a solid base. So yeah, just my final word.
True, and that base applies for everything. Personal finance to I don't know. I right now I can imagine, but it definitely helps you to be more organized
Oh
in your
yes.
head, to attack problems in a more logical way, and so on.
Troubleshooting. Trouble. I mean, you know very well that troubleshooting is the core of chemical engineering. Not only learning the concepts, but how to implement them in order to solve practical problems. You know, in the industry, if the pump isn't working, okay, what's wrong with the impeller? Fine. You know, then the question arises, hey, isn't that a mechanical engineer's job? Fine, mechanical engineer will come and fix it, but you need to know how it works. You know how important pumps are in fluid mechanics, pumps, compressors. You cannot teach fluid mechanics without pumps and compressors. So having proper knowledge about how they work and what they consist of, what different types are, you can't be a complete chemical engineer.
Yeah, I'm also with you on that. That you need to know everything, and the more you have knowledge of, the easier for the chemical engineer to troubleshoot. So, Asim, thank you once again, and guys, we'll see you in the following episode.
Thank you.
Bye bye. Thanks for joining us. I hope you enjoyed the episode. And before you go, I would really appreciate it if you take the time to share this podcast with your fellow colleagues, classmates, friends, or really anyone that might be interested on the topic of chemical engineering and its related fields. If you found this content helpful and valuable, please consider subscribing, rating, and leaving a review. Thank you so much for your support. It really means a lot.